How does gravity make things fall? When you let go of an object, why does it immediately start to move toward the ground, accelerating until it hits something? For centuries, gravity was described as a kind of attraction between objects. Then Albert Einstein discovered that gravity is actually a warping of space and time. But what does that mean exactly? Maybe you've seen this demonstration, which uses a sheet of stretched rubber. A heavy object like the sun warps the space around it, causing the paths of nearby objects like comets to curve, or perhaps even orbit around it. But this is just a handy way to visualize the warping that Einstein described. It doesn't actually explain gravity. After all, the ball is only rolling downhill. Why does a ball roll downhill or an apple fall? I wanted to make a demonstration that would explain that. And this is what I came up with. I call it the space-time stretcher. It's basically a graph for charting the up or down motion of an object over time. It's similar to a chart of the stock market or a season of the Chicago Cubs. Now pretend for a minute that there's no gravity. If we let go of an object, it would just float there. Time would pass, but it wouldn't go up and it wouldn't go down. On our graph, it would follow a flat line along the time axis only. We can represent that line with a strip of colored tape. This is what happens as time passes. The apple stands still. If we tossed an object upward in zero gravity, it would continue going up at the same speed. Without things like air resistance or a ceiling to run into, it would go up forever by its own inertia. On our graph, it would follow a straight line slanting upward. Now let's add some gravity and see what happens. Gravity is like a bending of this graph of space and time. And we can make that happen by turning this handle. The more we turn it, the more our space-time graph gets warped, corresponding to stronger gravity. Let's repeat what we did earlier, now with gravity. If we let go of an object, it starts along the same horizontal line as before, moving only through time. Only now, space-time is warped. Notice that while the object is following the same flat line, now the time axis is peeling away. An object tossed upward also takes the same path as before, a straight line slanting upward. But when space-time is warped, things are different. To get a better look at what's happening to these objects with gravity, let's return the space-time stretcher to neutral. Following each object across time, now the apple, instead of just floating there, starts to move downward, and it accelerates as it goes. For the same reason, the baseball goes up, stops, and comes back down, eventually passing its starting point. This is how gravity works. All freely moving objects follow straight paths through space and time. But if space-time is warped, as it is where there's gravity, then those paths appear to change. Let go of an object, and even though it's passing only through time at first, the warping will cause it to begin moving downward through space as well, completely on its own. And an object tossed upward will slow down, stop, change direction, and return to where it came from. And that is how gravity makes things fall. Thank you for watching.